welcome to another math tutorial. In this video, we're going to go over how to write linear functions. Maybe you have a graph of a line, you want to write the equation of that line, or maybe you're given just some information about the line and you're asked to write the equation of that line. So that's what we're going to do in this video. Hopefully you've already seen the videos or have some background in graphing equations of lines, because I think that's going to be helpful as a prerequisite to this video. So that said, let's jump right into the first example problem. Okay, the directions here are to write the equation of the line shown in the graph below. Okay, so you should have some familiarity with equations of lines, and specifically with the slope-intercept equation of the line, y equals mx plus b. Now, when you're asked to write the equation of a line, as we are here in the directions, typically you're asked to get to this form of the line. We can do some algebraic manipulation to turn it into standard form, but it's pretty standard that you're after slope-intercept form. So I like to just start right here. And what we need to figure out based on the graph shown is what's the slope and what's the y-intercept. If I can figure out these two numbers, then I'll replace the m and the b with those values and it'll be finished. So I'll start with the b, which is the y-intercept. I can look right here and I can see where the graph is crossing the y-axis. It's crossing the y-axis at the point 0, -2, which makes the -2 the value of b. Okay. Now slope, I need to pick any points on the graph. It doesn't matter which point. So maybe I'll look at this point and this point. And I'm just I can either use the slope formula or I can just count between them. To get from this point over to this one, I went up 3 and to the right 2, which makes the slope of this line 3/2, or 3/2. So I've got the numbers that I need. I can just now plug them in. Y equals 3/2 x plus, and the b value is actually negative, so I'm going to rewrite this. Instead of writing plus -2, I'm going to write y equals 3/2 x and just -2. All right, so there's the equation of that line. Now it's a pretty easy example for the most part when we're given a picture of the graph, if we're given the line to look at, because it's pretty easy to visually just spot where it crosses the y-axis and count out slope anywhere on that line. You're not always going to be given that information. You're not always going to be given that visual. So we need to go over another way to do this type of problem. All right, back in my 1.3 video on graphing linear functions, we presented all the different equations of the lines, and we presented point slope equation of a line, but we haven't really done anything with it yet. And so today is the day, in this video is when we're going to actually start using this equation of the line. So almost always when I am asked as part of the directions to write an equation of the line, this is what I'm going to use. I'm going to use this point slope equation of the line. And in order to use this, you need two pieces of information, and it's in the title of the form of the line. Okay, so you're going to need a point, which is here. You need an x, y point that the line goes through, and you also need a slope of that line. If you know those two things, if you know a point and a slope, you're going to plug those numbers into these three spots, and then you're going to work the equation out from there. So I have a few examples to practice together so you can kind of see what that looks like. Okay, this first example, we want to write the equation of the line given that the slope is 3/2 and it contains the point -3, 4. Now, certainly if you wanted to, you could do like the first example problem where we graph this and you can see then the y-intercept and the slope, and you can go from there. But I don't want to spend the time graphing this. Instead, I'm going to use just an algebraic approach, and I'm going to do this point slope equation. This y minus y1 equals m times quantity x minus x1. Now, in this form, The slope 3/2 is going to go in for the m. And then the point is going to be your x1. So the x value is going in for the x1, and the y value is going in for the y1. So we're just going to plug those numbers into those spots. So we have y minus 4 equals 3/2 x. Now you do have to be careful right here. We are putting a negative number in behind a minus sign. So we are going to be subtracting a negative, and when you subtract a negative, it changes to positive. So I'm making that change to plus because of the subtracting of the negative number, okay? It can happen over here too if the y is negative, so just be careful in both places. Now, once you've done this, once you've put your 3 numbers in, there's 2 steps to finish this. We're going to distribute that slope. So I'm going to have y minus 4 equals 3/2 x plus, now 3/2 times 3 is not going to come out evenly. It's going to be 3 times 3 is 9. So 9/2. And then I'm going to take this 4, I'm going to add 4 over to both sides. So that's going to give me y equals 3/2 x. Now I need to add 9/2 and 4. So let's see that worked out over here kind of as scratch work. 9/2 plus 4. Now 4 is the same as 4 over 1, right? You can't add these two fractions together when they have unlike denominators, so we have to fix that. So 9 over 2, and I'm going to change 4 over 1 to 8 over 2. So I just doubled that fraction. Then I can add 9 and 8 together and get 17 over 2. So that kind of scratch work is going to need to be done probably quite often in these problems. And if you can do it mentally, great. If not, there's no shame in just writing out a couple of steps of scratch work to get there. So there's point slope. Starting with point slope, plugging in the point and the slope and the steps it takes to then get to the equation of the line. All right, next problem. We again are wanting to write the equation of the line. So again, when I see those directions, I think to myself, use point slope. Okay. Now, what is missing in this problem, right? I'm given 2 points, right? Passes through the points there. So the slope is missing. We have to find it first. We can't proceed with this problem until we know what number needs to be put in right there. So what I'm going to do kind of as scratch work, kind of off to the side. Okay, so let's come over here. Kind of scratch work off to the side. I'm going to find the value of the slope first. So my slope, using these 2 points, I need to do y minus y over then x minus x. And hopefully you remember how to do that. If you don't remember how to do it, I did teach it in sections 1.3's video, and I also have a math minute on how to find slope between 2 points. So go back and watch one of those videos if you need some more instruction on this. Slope then is 4 minus 1, 3 over minus 1 is negative 2, or we're probably going to plug it in as just negative 3/2 like that. Okay, so we've got our slope. We actually have, we only need 1 point. We have 2 points. It doesn't matter which point you choose. This 1, 1 looks a little bit simpler than this because there's no negatives and the numbers are smaller. So I'm going to use this as my x1, y1. And so plugging in, I'm going to have y minus 1 equals negative 3/2 times quantity x minus 1. I'm going to distribute negative 3/2. So we have y minus 1 equals negative 3/2 x, the negative times negative will become positive, and 1 times 3/2 is 3/2. And we're going to add the 1 to both sides to cancel that out. Adding 1 so we get a common denominator is like adding 2 over 2. Okay, so I can add those fractions together. We get y equals negative 3/2 x plus 5/2. Okay, we're going to do one more problem like that because I want to do one more with the 2 points because that's kind of the most complicated one that there is, as you have to do this scratch work to find slope first. Okay, here we go. Just like the last problem, we're asked to write the equation of the line. We've got a couple of points that the line passes through. If you think you understood the last problem just fine, I would encourage you to pause the video and work this out on your own, and then just fast forward to the end and see the answer, see if you got it right. If you didn't, then you can play it back and watch the whole presentation of the problem. But writing the equation, here we go. We're going to use y minus y1 equals m times x minus x1. So I'm going to use point slope. I am going to need the slope. So over here, let's do that. The slope, I'm going to do y minus y divided by x minus x. So the slope is going to be negative 8 over 0. So the slope is undefined. Now, this is one of the rare cases where I'm not going to use point slope. Okay? If you recall, if the slope is undefined, then we just have a vertical line. And how do we write the equation of a vertical line? The vertical line equation is just going to be x equals, and I need to know what the x-intercept is. Where does this line cross the x-axis? Well, the x value of both of these points is 7, which means it's going to cross the x-axis at 7. So my equation is just x equals 7. And that's it. So a little bit different than the last problem. It was the same exact directions, same exact presentation of information, but the result of what we had made this play out just a little bit differently. And actually probably a little bit easier if we recognize that. Especially if we recognize it out the gate. If I saw these 2 points and they shared 7 as their x value, could have just jumped from problem to answer right away. Okay, I want to end this video with a little bit of discussion on parallel and perpendicular lines. And you should know a little bit about this from a course in geometry probably before you've gotten to this course. So hopefully this is not all brand new information. We've seen this before. So let's kind of discuss this. Here, parallel lines. I've got a picture of parallel lines. Parallel lines are lines that do not intersect. Okay? Because they don't intersect, that means that the slope, right, the vertical and horizontal change is going to be the same on both lines. If that change was different, then these lines would eventually cross paths. So what we need to know is for parallel lines that the slopes are the same. Okay? Now let's see an example problem where we apply that information. Okay, here we have a very common type of problem. Again, we're asked to write the equation of the line, but what's different about this is we want to write an equation that is parallel to this line. Okay, so the information presented is a little bit different here. But again, anytime I see, let's just go back to this. Anytime I see write the equation of a line, I am going to use point slope. You know, it works for every single case except the vertical line. But as we saw in a previous example, if we can spot the vertical line, then that problem's easy too. Otherwise, this is what I'm doing 100% of the time. Now, to use this, I need a point. So I have that. Right, here's my x1, y1. And I also need a slope. Well, the problem hasn't explicitly said the slope is blank, but we have some information that we can use. We want to write a line that is parallel to this line. Well, the slope slope of this line is -2. And we know that for parallel lines, we want to use the same slope. Okay, so that -2 is what we are going to use in our equation. Okay, so let's go ahead and drop these numbers in. We got y minus the y value of 3 equals -2 times quantity x minus, and the x is -5. That's going to flip that minus to +5. All right, we're going to distribute -2. So we have y minus 3 equals -2x minus 10. We're going to have to take this 3 over by adding it. So we get y equals -2x minus 7. That is our line that goes to this point that is parallel to that line. Okay, we're going to end this video with perpendicular lines, some vocabulary here, some information, and then we're going to see an example problem. So perpendicular lines, we should have some knowledge of this already, some prior knowledge. Two lines are perpendicular if they intersect to form a right or 90-degree angle. So right here, where the lines intersect, is a 90-degree angle. Now, as far as their slopes go, what we need is information about their slopes. There are two kind of definitions here, one that's really going to help. What is true with perpendicular lines is that the product of their slopes is -1. Okay, now that's nice, it's neat, we can use it possibly, but it's not super helpful for writing equations of lines. The second part is the slopes of perpendicular lines are going to be opposite signs and reciprocals of each other. Okay, so that's what we need. That's what we're going to carry into the next problem as we do our final example problem of this video. Okay, our final example problem. Write the equation of the line given that we want to be perpendicular to the line 2x plus y equals 2. We want to pass through this point. So again, like all these problems, write the equation, tells me use point slope. Okay, I have the point. We're going to use this as our x1, y1. So that's taken care of. What we don't have is the slope. Okay, so we got to figure that out. What are we going to put in for the slope? Once we figure that out, it's going to be pretty smooth sailing to finish this problem. So to find the slope, I need to come up to this line. I want to be perpendicular to this line. As it's written, I can't tell you what the slope of this line is. I need to solve this line for y. So I'm going to rewrite this as y equals, I'm going to subtract 2x to this side, like so. So the slope of this line is -2. Now, I don't want to use that slope. If I use -2 here, then I'm making a parallel line. I don't want the same slope. To be perpendicular, I have to change this slope. So this slope, which is -2, which is -2 over 1, I have to do the opposite and reciprocal. Okay, so the perpendicular slope, there's slope and there's my perpendicular symbol, needs to be opposite sign. So whereas this is negative, I want this to be positive, and the 2 over 1 becomes 1 over 2. So that's the slope that I am going to use over here, +1/2. So let's plug it all in. Here we go. We're ready to solve this problem. Y minus the y of 7 equals +1/2. X minus -1, change that to +1, like so. I'm going to distribute 1/2. So y minus 7 equals 1/2x. 1/2 times 1 is 1/2. And then I'm going to add this 7 to both sides. Now 7 is the same as 14/2, so that I can add these numbers together. And I'm going to get, let's write it over here, y equals half x plus 15 halves. Okay, that concludes this video. I want to thank you for watching and tuning in all the way to the end. If you have any comments or questions, please drop them in the comment section below. If you think you could benefit by a few more example problems, just tune into the next video of this playlist where I'll work a couple extra problems for you. If you found this video helpful, I encourage you to support the channel with a thumbs up on the video, and I'll see you in the next one.